Hey guys, it's Mrs. Stewart. I'm here today with part 1 of 2 of my absolute value inequalities videos. This is the basics and one example, and then if you want to get into more examples, you can go ahead and watch part 2. Absolute value inequalities work similar to absolute value equations, but the inequality sign makes things a bit more complicated. Let me show you what I mean. If we go back to absolute value equations for just a minute, I want you to recall that the absolute value of x equals 4 means that x is 4 units from 0 on a number line. If you need any refreshers on absolute value equations, I do have a video on that as well. But 4 units from 0 means you would go 4 units to the right, so it could be positive 4, or you can move 4 units to the left, giving you negative 4. So if this were an equation, it's very simple. We would be done. We would have our 2 answers. Now, with an inequality, the absolute value of x is less than 4 means x could be any number less than 4 units from 0 on a number line. So think of it the same way as far as you go to the right 4 units and then you go to the left 4 units, but this time you don't have to be exactly 4 units from 0. You have to be within 4 units from 0. So your solutions could be anywhere in the green area. So you can see the little worm here is kind of showing you. You can go 4 units to the right, 4 units to the left. Anywhere in that area would be considered a solution. I also want to note that the open circles mean that we're not including 4 or negative 4 itself, because less than means smaller than but not equal to. So the open circles mean you cannot go as far as 4, but all the way up to 4. And all the way down to negative 4. The solution can be written x is greater than negative 4 and x is less than 4, or more commonly we write this in one statement. We write negative 4 is less than x, which is less than 4. And I like to read this x is between negative 4 and positive 4, which I think makes sense to most people. Now I want to do a greater than one, and this time I'm including the or equal to option. So we have the absolute value of x is greater than or equal to 2. And that means any number more than 2 units from 0 or equal to 2 units from 0. So to consider equal, we close that circle in, and more than would be anything greater than or anything farther than 2, so to the right. You can also go 2 units to the left and past that, which would give you more than 2 units from 0. So your solution would be anything 2 or to the right forever, anything negative 2 or to the left forever. And the closed circles indicate that the solutions are up to and including the endpoints this time. And to write these solutions, we always use the word or. So this solution can be written x is greater than or equal to 2, which would be the 2 and everything to the right or greater than, or x could be less than or equal to negative 2, which includes the left-hand side. So maybe you've noticed the direction of the inequality sign determines whether you use and or and how the graph is going to look. So I'm going to start with less than or equal to. If it's in the less than direction, we use the word and, which means the solution must meet both conditions. So let me show you what I mean by that. Here's an example. The absolute value of x is less than 3. So this means x could be 3 units from 0. Less than 3 units from 0 on a number line, which means that they are less than 3 and also greater than negative 3. So if you take a look at a number line, you would be talking about everything from positive 3 down to negative 3. And since we weren't including the or equal to option here, the circles are open. Now you have to understand that this means you would be within that region. You can't go past the 3, you can't go past the negative 3. The and is important because it sets the boundary. So to say x is less than 3 without also saying x is greater than negative 3 would allow us to go to the left for infinitely. So in other words, if we started at 3 and we just said less than 3, it would keep on going forever. All right, and so that would mean that our little worm can go to the left infinitely. However, we must set that lower boundary as well, because as you know, if the worm keeps going to left, he will eventually get farther from 3 units from 0. So you need to stop the boundary at negative 3. That's why and is important. Less than 3 by itself, without the lower boundary, would mean that we can include everything infinitely to the left. And so stopping with that lower boundary means we keep that little worm where it's supposed to be. Greater than or equal to uses the word or, which means that your solutions only need to meet one of the conditions. So the graph is going to look a little different. Here's an example, and we'll use 3 again. The absolute value of x this time is greater than 3, and that means x has to be more than 3 units from 0. So we're talking about the numbers not exactly 3, but everything larger, not exactly -3, but everything smaller. Okay, and or means it can be in either or, either to the right or to the left. It doesn't have to meet both conditions. So our worm can go off to the left forever or to the right, right or left forever. Okay, now we're going to get into an example, and this is probably more accurate what you'll be seeing in your homework. The absolute value of x plus 2 is less than 5. So we want to remember everything we just learned about these absolute value inequalities. This means that x plus 2 is less than 5 units from 0. So what we're going to do is take that x plus 2, and we're going to say that it could be less than 5, and because because we have the less than, we use the word and, x plus 2, flip that sign around, is greater than -5. This just means it's between 5 and -5. So like in our last example, the little worm has to stay within that little green region. Now we're going to solve each one of these. So starting with the first one, using inverse operations, I subtract my 2, and I just do the math. X is less than 3. So by itself, that would look like this. Open circle at 3, everything to the left. But we do have another condition we have to consider. Let's subtract 2 from both sides on this second inequality. We get x is also greater than -7. So that's a lower boundary for us. X has to be greater than -7. So by itself would look like this. Open circle at -7 and everything to the right. But because of the word and, we have to consider where you see both colors there, or where both conditions are met. So in other words, our graph's going to stop there. We're going to have from -7 to +3. And we typically write this answer as one statement. -7 is less than x, which is less than 3. Or in other words, x is between -7 and +3. So those are the basics, and I have more examples and a little bit more complicated examples in part 2 if you're interested. If you like this video, click like and don't forget to subscribe. If you're interested in the unit I have that goes along with this video, click the link below. Thanks for watching.